Hello, everyone. I know that this is a post-lunch session, so there will be a tendency that you start feeling a bit sleepy. I won't talk too much about technical detail. I'm here from HOOQ, and I'll start sharing our journey moving from 4.5 years ago until today, and how we deliver our product. So, HOOQ, its tagline is delivering a million story for a billion user. We offer best local and Hollywood content to our customer. We also have a fresh local fresh content that comes 90 days post theatrical, as well as the classic libraries. We are available in 5 markets as of today. Uh, we are available in Philippines, in Thailand, in Indonesia, India, and Singapore. The funny part of this market is that the network is not great yet, except for Singapore. So that's one of our key problem that we are trying to solve when we build our product. We have a last mile issue with network, especially in countries like Indonesia, Philippines, India, and Thailand, which is interesting. So that's one of the key things that we are going to discuss today. You can enjoy HOOQ in our native app. It's all homegrown built. We build everything in-house here in Singapore, and then we run engineering team both in Singapore and in Indonesia. You can enjoy in Android, iOS. If you have Android TV box, that's one of the client that we heavily support. You can enjoy it in Apple TV, Amazon Fire Stick, and other streaming sticks. This is one of the key capabilities that we built, which is PWA, mobile web. You can enjoy playback without downloading the app, and this is proven to be really great offering for our user. On top of that, we also make our service available on smart TV. You can enjoy a widescreen experience with at home with your family. This is one of the thing that we're building. Among that, we also work with enabling our API, the infrastructure that we built, to be available on other digital partner that they want to build video playback experience without the needs of running the video workflow or the complexity of managing video ingestion and delivery. So today, I'm going to share with you our experience on how we build that service, how we build the architecture, and I will share with you as well on the architecture evolution from the very beginning to 4.5 years ago until today. We've been in the market for 4.5 years, and then we start small as other startup. We start very small with just 5-person engineering team. I was one of the first engineers hired at HOOQ, and over time we grow the team. We get more customer, we get more user, and then we start seeing a lot of problem that we haven't discovered before. So this is how I stage how we consider ourselves. The first few years, in the formative years of HOOQ, it's all about getting up and running and how can we make the service available to our user. And then when we start growth, we are talking about serving requests from tens of thousands requests per day to 1 million requests per day. And that's where we start feeling that the traditional way of delivering software does not really relevant anymore. There are a lot of things that we learn along the way that those does not make sense. So that's what I'm going to share with you today. So in the very beginning, we started off with a very simple architecture. We call it no architecture at all. So it is just basically a very simple instance, running everything in EC2. It was written with Node, not ES6, and then we run transpiled code in production. And the mission here is very simple. It's just about how can we get noticed, how can we serve video for our user without thinking about scaling it into a million playback requests per day. And the mission here is that how can we understand what the user really need, whether they enjoy our content or they just try it out without committing to our service. So this is really a hard problem to start, especially in Southeast Asia. You're talking about network that is not mature, last mile issue. Sometimes you will see that something just go wrong without knowing exactly what's happening. So this is how it looks like, right? We have a Node ES6, as I mentioned before. We have Nginx in front of it. We're using Postgres to store everything. Basically, we put a lot of bad decision in the beginning because we just want to get it out of the market. We're using EC2 and autoscale with ELB. But one thing that I realized that we really invest from the beginning is instrumentation. We put a lot of sensors in our code. We make a lot of basically analytics from the get-go. From the very beginning, we have put everything in there, so that it is also part of our DNA that we ask ourselves as a problem-solving process. We keep asking whether is this the right solution, or is this something that do we really solve the problem, or is this something that really is that efficient? So that's the part of the question that we keep asking ourselves as we grow the team. And I can say that we're a proud customer of New Relic. We have been using New Relic from the beginning. And as a company that is just started, we do not want to spend our time and people, all those brain powers, to build something that we can offload. So we can focus on building a customer experience for our customer, building the product and building more capability. So instrumenting something is not really, it is important, but it's not directly impacting the capability of our product. So with New Relic, it's really lift us to a level where we do not really need to worry anymore about the system. We get everything in there, and then we can learn as we go. We do not really need to spend a whole team to manage instrumentation or monitoring. As part of the instrumentation, we also look at a couple of metrics for our system. We look at the latency, network latency, API response, the throughput. We also want to make sure that people are using our service. So we look at throughput, and we want to see whether the amount of servers for us to run the service is enough to cater the load. We do a lot of custom events for us to understand what is actually happening in the system, but it's not everywhere. We put certain instrumentation in a very critical path of the API, certain endpoints, and then for this snippet, this shows that we instrument, we fire events for every playback request that comes to our API. So as you can see, it's very straightforward. It's a no-brainer. And then immediately after we have that, we can query right away in near real time. So this is something that we do not really need to spend anything on engineering team. From this very simple information that we can get from the instrumentation without basically investing anything on engineering team, we can have better view if, let's say, you want to see a data in time series manner. It's also something that we can get without any change in the code. We can also have a better, more granular view on what is actually happening. We can fetch the data based on the attribute that we send. Those are one of the capabilities that we basically take benefit of. And we also do a lot of instrumentation on our mobile client. This is, again, one of the key things that we want to understand how the user behave. How is our application serve the user? We want to know where is the bottleneck. So this is also just a small snippet that you can put in our that we can put in our app, and you just get the result right away. One key thing that we learn is that the more we present the data to everyone in the company, they start learning how important it is. We cannot tell ourselves as a data-driven company yet, but we are rather a data-informed company. When you can always start with assumption and use the data to prove that assumption. We also make a lot of dashboards so that our user, our customer, have we can learn more about our customer. We make the data available to everyone in the company, so that it kind of building a culture for everyone. Whenever they need something, they can just go see the dashboard and then they get everything that they need. So that's basically the end of the first year when we start the business. That's basically a stage where we kind of in an okay state, and then the more we get noticed, the more we get partnership with other company in the region, we start getting more user. We at the point we have 14 million registered user registration every daily, right? Every day. So that's when we start realizing that the existing solution that we built, it just does not solve the problem. You can't really scale the service that we have that we built earlier with ES6 transpiled code. It has a lot of problem when it runs at scale. So naturally we take the approach, the trend, and then we follow that, right? We learn about microservice, so we start thinking about, let's break down the monolith API into smaller services, right? But we know that microservice is not a free lunch. You got to think through, you got to architect right. So in our case, we don't really take it as is. We do not just build service as it is. So, but then we start doing that. We have from one monolith API now we have around 40 services running in production. We started with discover service, we started with playback service, user service, and any kind of service that we can do, we just build it. And the team grows. It started from 5 people. Now we have 40 engineers, and they're located in different places. And it's just getting hard to communicate on one concept. And we just basically let everyone decide on what do they think best at a point in time. So we start getting breaking down things, and then we start having more service. It's just getting more complicated. So the setup with these services and the nature of working with a team in distributed location, they tend to have a solution on themselves. We do not talk much. We do not communicate well. So we have now we come up with a new technology. We have ES6, we have Go, we have Lua, we put Nginx, we have Kong, we have Lambda. Now we start putting more serverless in. We are using ECS, and it just keeps growing. And especially when we're working to make our service available in the new market, it's different level of complexity. The network profile is totally different. The distribution of devices is different. I can give you an example. In Indonesia, we can still see devices with Android 4.2 or 4.3 is still available in the wild, and then they don't even support TLS. The same thing with India. In some part of India, there are still a majority of devices are running a very old version of API. But we also want to serve those clients. So as part of this complexity, we also see that our internal system is also getting more complex. The amount of data that we process, the amount of video stream that we serve every single day just keeps growing. And then we learn from that, hey, it looks like doing things the way we do right now does not really make sense. We got to change the way we approach a problem. And that's where we start thinking about developing something more distributed. And we also take the approach of multi-region deployment. Now we make our service available clone in AWS Singapore as well as AWS Mumbai. So this is probably the best model as of now, but we may need to revisit that later as the team, the scale grow. And then we are looking into surfing with multi-CDN, find the best CDN in the market that can serve well better than the big CDN player. So I'll just go through the next slide. This shows us how the architecture look like now. This is just a snippet of one API that we built. We run this API in Singapore and in AWS Mumbai. We're using a lot of lambdas function here to synchronize between the two. And it is not the straightforward in the beginning, but thanks to the technology that we have provided by AWS, is something that is manageable. You can have a homogeneous architecture, the same code running in totally different region, without being hectic in syncing up the state or synchronizing the data. So that's basically where we the growing pains end, and now we are into the next stage, which is we start rethinking on how can we, as a team, as an organization, can we build a better service as well as better architecture. So from the learning of the past year, we know that it's very easy to get messy. I'm just going to share a snapshot of our AWS account. So this is how it looks like now. We have around 390 EC2 instances, 400-ish volumes, 65 elastic IPs, 100, about 200 probably now, elastic load balancers, 150 security groups. We are running 40 to 60 lambdas now. And then we start adopting ECS, ECR. We have 47 ECR, 21 ECS cluster, and we build a new service every day. So we are running a new stack while we're still running the legacy ones, because simply that's how it works. You kind of that's the real life that we have to deal with. So in rethinking a platform sanity, we got to back to basic. I know that sometimes we tend to follow the trends. We just pick something new and then does not really think in the long run on how to operationalize that. That's one of the key things that we take into consideration. So about the rethinking of platform sanity, we go back to the principle of software development, single responsibility principle. So when we start building a new service, we do not just pick it just for the sake of building it. We take the approach where we need to define what is small and what is big. Small means that it's just enough to solve a particular problem without being meaningless. We do not build a service where it picks a data from an S3 bucket or pick something and then send it to Slack. We don't do that. But we build something that is enough to solve one business use case. Like, for example, Playback API. It's clear that it solves Playback API. It serves Playback API. But it does not convolute it with itself with other responsibility. And then we make a convention for all these services to communicate through a certain negotiable interface. a service can expose itself as a HTTP service. We're in the midst of embracing gRPC. So here we can think that it's pretty much conservative, but we know that by taking certain, well, new technology does not always solve the problem. You cannot just pick one technology and then boom, it's a silver bullet. You get everything solved. So we tend to stick with something that proven works and then scale that. And then in the end of the day, building service, building new service, or scaling system, we are still working with people. So we promote collaboration, deciding interface together. It's not about you provide a service and don't really care about how other team is going or might use that. And then we also realize that standardization is important, and making a predictable deployment is also very important. So you can easily achieve that with a standard practice in, let's say, ECS deployment or serverless Lambda. So we came up with convention within the team, within the organization, of how should a service look like. We came up with a project structure, development and testing model, and deployment model. So if I look back now in our infrastructure compared to 2 years ago, our infrastructure now is pretty much homogeneous. It just looked like the same service, and it's encapsulated. You can't really tell what it's actually doing unless you know exactly what the service is doing. So this is how it looks like for one of the service that we just recently built. This is an example where we use we pick that principle into implementation. So this service now is, well, it's responsible for video ingestion workflow, managing video management. It runs in its own ECS cluster. It's very easy to deploy. We have 3 different states of environment. We have development, test, and production. And it's just very easy for us to change something and then see it in production. And the turnaround time is just about 1 minute for every changes. That's really up to us on how we can implement that. It's independently scale up and down, and it has its own data storage. It has its own queue, and we stick with a couple of interfaces that we provide. We expose this service to the external ones. We work with SNS. We provide an SNS topics. You can call this service through REST API. You can also subscribe to the SQS, SQS of this service to get any update that happens. And then we integrate a lot with Slack. So we make the life of people in the organization easier by doing that. It also get us to a level where it simplifies a lot in terms of build and deployment. Again, I mentioned about it's homogeneous. Everything is just ECS. Everything is containerized, and everything is Dockerized. You cannot. It's a standard. So in this case, we're heavily using ECS and ECR. The build phase, it's always build and then push the image to a registry, and deployment, it's done through Jenkins. Everything is automated, and we can predict what will be the outcome of a certain version of our software. And turn out that this is really, really important. It's more than just following a trend or following the hype, but it's more like how can we be more consistent and be more predictable in the software that we build. So consistency does matter, and then we really stick to that. So I could not say that we're kind of in a perfect state yet. I mentioned that now we have 3 stages, and probably next year I come up with a new stage where we revisit what we have. That's part of the problem solving that we are doing, keep learning and then revisiting. There are a couple of lessons that I would like to share. from the journey that we've been in the market for 4.5 years, there are a couple of lessons here, right? If you're just started, if you're a startup, I do not think it is wise for you to run a huge workload in a data center. So one of the key things that we learn is that you got to build your product iteratively. You don't want to spend million to run infrastructure, and then while you're still experimenting. And I think AWS provides that flexibility. We start off with EC2, just a two-piece of EC2 instance. Now we are running hundreds of it, and it's just a value of providing flexibility is really really important for a business like us. And then evolve the architecture as we grow. I keep mentioning about the team growth, the number of the team being distributed. It is also part of the consideration when we build the architecture. The architecture here, we treat architecture as a living thing. So the team is also part of the architecture. The way we design problem-solving approach is also part of the architecture. So it just evolving, and then you got to take that as your pet, probably. It's a living thing. And then it's hard to be a data-driven. I can share that, but we have to. We take the learning that we have to be always data-informed. It is okay for you to make assumption, but then you got to be ready to prove that assumption with data. You cannot come up with the data upfront, but when you have an assumption, be ready that, hey, you got to prove that. And if it's wrong, then it's wrong. You change and then repeat. And then as a team, as a company that just basically start from the very beginning, we basically write everything from scratch. I think it's really important for us to spend every energy, every resource, people, manpower, brain power, into building the product capability instead of building something that you can offload it to somewhere else. So we would rather to spend more time on that and then building product as we grow, rather than spending time in maintaining infrastructure or running a high load of data analytics to the opposite of the building product capability. So I think that's where we are now. I've shared probably everything, the lesson, the journey that we have shared from 4.5 years ago until today, and hopefully we can take the learning together, right? So that's all. Thank you.